Hi everyone, we are going to discuss about diagonal scales. So far we have discussed about plane scale. So now we are going to discuss about diagonal scale. So here the diagonal scales are constructed to represent two decimal points of a particular dimension. So here we can represent the two decimal points of a particular dimension. So plane scales we have represented only one decimal point for any particular dimension. So here, for example, in plane scales, we have represented only one decimal point. Okay, like meters and decimeters, it means 1 meter is equal to 10 decimeters. So, in other hand, we can say that we can represent in plane scales point 0.1 or point 0.2 like that. Okay, that means one decimal point we can represent in plane scales. So here 1 meter 1 decimeter, 1.1 meters means here 1 meter 1 decimeter. Similarly 1.1 centimeters means 1 centimeters 1 millimeter. Like that, one decimal point we can represent. That means one main unit, one sub unit we can represent in plane scale. Whereas in diagonal scales we can represent two decimal points, means 1 meter 1 decimeter 1 centimeter, like that. That means 1.12 meters, 1.22 meters, 1.23 meters, like that. Okay, so next here, so already I said, whereas in plane scale we cannot represent two decimal points like 1.12 meters or 1 meter 10 decimeter 2 centimeters. So like that, two decimal points we cannot represent in plane scales. So this kind of two decimal representations can be done by diagonal scales. Okay, so the purpose of diagonal scale is we can represent the two decimal points for the main unit. Okay, that is the advantage of diagonal scale here. Okay, so once again here, last point, go to the last point, that is it means we can represent unit, its subunit and subdivision of subunit. Okay, that means unit, that is 1 meter, its subunit, that is decimeter, and the subdivision of subunit means centimeters. Like that, two decimal points we can represent in diagonal scales. Okay, so next we discuss about the principle of construction for constructing a diagonal scale. Okay, so go to the first point. Let us consider xy is subunit of a unit as shown in figure. So here I have drawn a line, so that is considered as xy. So here consider xy is a sub unit of main unit. That means if you consider main unit as 1 meter, so xy is the sub unit of the 1 meter. That means generally a main unit will have 10 subdivisions. That means here xy is the first subdivision of the main unit. Okay, so similarly, now draw a perpendicular line from y as shown in figure with a suitable length. With a convenient length, draw a perpendicular line from y and give the end point name as z. Okay, draw a perpendicular line and give the name as z. Okay, so next, join xz and divide the yz into 10 equal parts and name it as 1 to 10. So that means here join the x point, so x point to z point here. So join like this, then divide the yz here. So this yz equally divided into 10 equal parts. So like this, give the name as again 1 to 10. And next, draw parallel lines from these points to xz line as shown in figure. So here from each point we have divided, draw a parallel lines. Those lines should be parallel to the xy. Okay, draw the parallel lines like this, and intersecting points give the name as again dash 1 dash 2 dash 3 dash up to 10 dash. Okay, so next point. The next point is, from the principles of geometry we know that the similar triangles have their like sides proportional. So here by these parallel lines we can consider any some number of 10 number of similar triangles. Okay, so with reference to the xyz we can consider 10 similar triangles. So here we know that their like sides will be proportional to each other. So here consider two similar triangles xyz and 7 dash 7z. So consider xyz and 7 dash 7z. Okay, these are the two similar triangles. So from the principle of geometry, for the two similar triangles, we can write it as 7z by yz, 7z by yz equal to 7 dash 7 by xy. Okay, 7z by yz, 7 dash 7 by xy. That is the formula obtained by the principle of geometry. So by this we can write it as 7 dash 7 is equal to 7 by 10 into xy. So here 7 dash 7 equal to, we can write it as 7 by 10 into xy. That means here, so xy we have taken to the left side. Okay, so 7z by yz, so 7z by yz. Okay, 7z is considered as 7 units. Okay, and yz is considered as 10 units. Okay, just like a dimension. So here 7z is considered as 7 units, that is 7, and yz is considered as 10 units, so 7 by 10 into xy we got. So finally it can be equal to zero point 0.7 into xy. Okay, total 7 dash 7 equal to, we got 0.7 into xy. That means here the 7 dash 7 to 7 dash distance is the seventh division of xy. Okay, generally for this division we need to divide it into 10 equal parts. Okay, so then only we can represent the third decimal point. So in that case we have drawn a parallel lines. So here this parallel line 7 dash to 7 represent the seventh subdivision of this subunit xy. Okay, so 7 dash 7 equal to zero point 0.7 into xy means it is the seventh subdivision of the subunit xy. So similarly, we can say that 1 dash to 1 is equal to the first subdivision of xy, and 2 dash to 2 is equal to the second subdivision of the xy subunit. Okay, so it is clear that each parallel line is equal to the subdivision of the subunit of the main unit. So by all this we can easily understand that each parallel line is equal to the subdivision of the subunit. This is the subunit and this is subunit of main unit. Okay, that means here after construct by while constructing the scale, we need to divide the main unit into 10 equal parts. So in that, again we need to divide the subdivision into uh, sorry, after dividing the subdivision into 10 equal parts, we need to draw a diagonal lines, then we can get the subdivisions of subunit. That means here first remember, so xy is the, sorry, xy is the subunit of the main unit. So in that xy we need to know the subdivision of the xy again. So here these parallel lines represent the subdivisions of this subunit xy. So by this we can construct a diagonal scale, okay, for representing the two decimal points of main unit. So I hope you understand this principle of construction for the diagonal and introduction. And if you once go through the example problem, you can easily understand. Okay, so wait and watch for the next video. In next video I give the example for constructing a diagonal scale, and I hope you understand this video. So if you still have any doubt, please give a comment and try to share the video, and please subscribe to my channel. Don't forget to subscribe to my channel. Thank you all.